So in this question, we have to find out the disjunction of the statements Hyderabad is in India and 2 plus 2 is equal to 4. Now there are two types of connectives. One is disjunction and the other one is conjunction. Okay. Now disjunction means we are talking about the connective, the logical connective or, and here we have two statements. Hyderabad is in India and the second statement is 2 plus 2 is equal to 4. Okay. So what I'm going to do here is I'm going to assume that there is a statement P, which is Hyderabad is in India, as given to us in the question. I'm going to name the second statement as Q. So the first statement P is Hyderabad is in India, and the statement Q is 2 plus 2 equals to 4. Now, the agenda of this question is to find out P or Q. Basically, we have to find out the disjunction of the statements P and Q, and the disjunction of the two statements P, Q is given by P or Q, and they are connected by a logical connective OR. Okay, what is the statement P? The statement P is Hyderabad is in India, and statement Q is 2 plus 2 equals to 4. Now, when I connect them using the disjunction, when I actually calculate the disjunction of these two statements or connect these two statements using the logical connective OR, what I will get is Hyderabad is in India or 2 plus 2 is equal to 4, which has been given to us in option B. Hence, we can say that the correct answer to this question is option B. So in this question, we have to find out the truth value of 20 plus 10 is equal to 2 and 20 multiplied by 10 is equal to 200. Basically, in this question, we have been given two statements. One statement is 20 plus 10 is equal to 2 and another statement is 20 multiplied by 10 is equal to 200, and the agenda of this question is to find out the truth value of the conjunction of these two statements. All right. So what I'm going to do here is I'm going to name the statement 20 plus 10 equals to 2 as P and name the statement 20 multiplied by 10 equals to 200 as Q. Now the agenda of this question is to find out the truth value of P and Q. All right. So what is the truth value of P? The truth value of P is false because we all know that 20 plus 10 is equal to 30 and it is clearly not equal to 2. Hence, we can say that the truth value of P is false. Now, what is the second statement? The second statement is 20 multiplied by 10 is equal to 200. We all know that yes, 20 multiplied by 10 gives us 200. Hence, we can say that the truth value of the statement Q is going to be true. Okay, so here what we have is P and Q. Now, P is false and Q is true. So basically, we have to find out false and T, as in one input is false and one input is true. What will be the output of their conjunction? The output of their conjunction would be false. Hence, we can say that the truth value of the statement given to us in the question is false. Actually, truth value of the conjunction of the statements given to us in the question is false. Hence, we can say that the correct answer to this question is false, which is given to us in option B. Hence, the correct option is option B to this question. Okay. So in this question, we have to consider the statement Pn is equal to n square minus n plus 41 is prime. Then we have to find out which of the following four options is the correct option to this question. Okay. As you can see in all four options A, B, C and D, we are talking about two values here. P of 3 and P of 5. So let's first calculate the value of P of 3 and P of 5, and where P of n is defined as n square minus n plus 41. So what is P of 3? P of 3 would be 3 square minus 3 plus 41, which is equal to 9 minus 3 plus 41, which is equal to 6 plus 41, which is equal to 47. Is 47 a prime number? Yes, 47 is a prime number. Hence, we can say that P of 3 is a true statement, or we can say that the truth value of P of 3 is going to be true. Okay. Now let's calculate P of 5. So P of 5 would be equal to 5 square minus 5 plus 41, which is equal to 25 minus 5 plus 41, which is equal to 20 plus 41, which is equal to 61. Okay, now is 61 a prime number or not? Yes, 61 is a prime number. Now here P of 5 is a prime number, hence we can say that the truth value of P of 5 is going to be true. So here both P of 3 and P of 5 takes up the truth value as true, hence we can say that option D is the correct answer to this question, which states that both P3 and P5 are true. Okay, so what is the correct option to this question? The correct option to this question is option D. So in this question, we have to find out which of the following is not a negation for the statement for every x belonging to the set of natural numbers x plus 3 is less than 10. Okay, so here we have to consider the statement for every x belonging to the set of natural numbers x plus 3 is less than 10. And what do we have to find out here? We have to find out which of the following is not a negation for this given statement. Okay, so we'll go by option, we'll go option by option. Now, option A states that there exists a number x such that x belonging to the set of natural number for which x plus 3 is greater than equal to 10. Okay, now this is actually the negation of the inequality given to us in the question. In the question, it has been given that x plus 3 is less than 10, and x plus 3 greater than equal to 10 is actually the negation of the given inequality in the question. Hence, we can say that option A is the negation of the given statement. Hence, we will have to reject option A. Moving on to option B. It is false that for every x belonging to the set of natural numbers, x plus 3 is less than 10. Even though we are talking about the same statement here, for every x belonging to the set of natural numbers, x plus 3 is less than 10, but at the start of this we are saying it is false. Okay, so we are starting with the negation of the given statement, hence we can say that even option B would be rejected, because option B clearly states in some other words that we are talking about the negation of the given statement. Okay, now option C states that not for every x belonging to the set of natural numbers x plus 3 is less than 10. It's another way of saying that not for every x. Okay, that means not for every x is a negation of for every x belonging to the set of natural numbers x plus 3 is less than 10, because here we are saying not for every x. But in the question, it has been given that for every x belonging to the set of natural numbers, x plus 3 is less than 10. In option C, we are saying not for every x belonging to the set of natural numbers, x plus 3 is less than 10, which is again the negation of what is given to us in the questions. Hence, we will have to even eliminate option C, and we are just left with option D, which states that for every x belonging to the set of natural numbers, x plus 3 is greater than 10. Okay, now this is not the negation of what the statement is given to us in the question. Hence, we can say that the correct answer to this question is option D. So in this question, we have been given two statements, P and Q. Statement P states that x is odd. Statement Q states that x square is odd. Then we have to find out how can we represent x is odd and x square is not odd. Okay, so x is odd. We are taking the uh, statement P as it is. So we'll write P as it is. Here we have a connector, and that connective is AND, which is represented by AND, okay, which is represented by this caret sign. And here we have got P and something. Now, the statement 2, or I would say the part 2 of the compound statement states that x square is not odd. Now, Q states that x square is odd. Here it is given x square is not odd. That means we are talking about the negation of Q. If you're talking about the negation of Q, we can say that this compound statement x is odd and x square is not odd can be represented by P caret sign negation Q, okay, which has been given to us in option D. Hence, we can say that the correct answer to this question is option D.